Have you ever noticed how every structure of the solar system makes it appear calm? 8 planets moving in predictable orbits around the sun, satellites silently orbiting their planets. Everything acts like a perfectly tuned clock that has kept track of time for billions of years. This is one of the first scientific models most of us learn, and it leaves a strong impression on us. Our cosmic neighborhood is stable, even safe. But this leaves out something important. The solar system is not a perfectly ordered machine. It is the surviving remnant of an ancient period of chaos that hasn't quite ended. While thousands of rocks cut across Earth's orbit every day, millions more drift silently through space unnoticed. What's surprising isn't that collisions happen. What's surprising is how frequently they happen. When you stop looking at the solar system with simple diagrams and start looking at it with actual observations, it's a far more disturbing place. For centuries, people imagined space as almost entirely empty. The enormous distances between planets made collisions virtually impossible. But modern sky surveys say the opposite. Specialized telescopes are discovering new asteroids almost every night, and every improvement in our ability to observe the sky reveals that our neighborhood is far more crowded than we once believed. Growing catalogs aren't proof that there are more asteroids today than there used to be. They're simply showing how many we can't see. This awareness has shifted the way we think about risk. Most of these objects never approach Earth. Most are harmless. But that word most quietly reminds us that some aren't. The moon preserves the evidence. Unlike Earth, it doesn't have the weather, oceans, or active geology that could erase its past. Every crater is a permanent record of something coming from space at incredible speed. For a long time, these traces seemed like remnants of ancient history from the violent birth of the solar system. Then, spacecraft began to find new impact sites, proving that the bombardment never really stopped. Earth is experiencing the same environment, but our atmosphere and geology are constantly erasing the evidence. The moon doesn't show us a violent past, it reveals an active present. This awareness has become even more unsettling as we look more closely at home. Modern tracking systems detect fireballs entering Earth's atmosphere far more frequently than most people expect. Almost all of these burn up harmlessly, and most are too small to cause damage. However, most is not the same as all. In 2013, an asteroid about 20 meters in diameter entered Earth's atmosphere over the Russian city of Chelyabinsk. Obscured by the sun's glare until its final moments, the asteroid exploded with immense force high in the atmosphere. The shockwave shattered the city's windows and injured over 1,000 people, but the asteroid itself did not reach the ground intact. What most troubled scientists wasn't the explosion itself, but the fact that no one had foreseen it. At first, it seemed like a problem solvable with technology. Build bigger telescopes, find every asteroid. But the deeper astronomers studied near-Earth objects, the more they realized the difficulty lay in the geometry of the solar system. Detecting objects approaching from the direction of the sun is extremely difficult. Some asteroids are so dark they reflect almost no light, while others rotate in ways that constantly change how bright they appear. This isn't due to the inadequacy of our instruments. It reminds us that visibility is never guaranteed. The story becomes even stranger when gravity comes into play. Many people imagine Jupiter as Earth's giant protector, diverting dangerous objects away before they reach us. Sometimes it does exactly that, but sometimes Jupiter redirects objects onto new paths that eventually intersect Earth's orbit. The same planet can reduce the danger in one instance while increasing it in another. There is no simple role for the largest planet in the solar system because gravity rarely behaves in simple ways over millions of years. Even the idea of an orbit is more complex than it seems. We imagine planets and asteroids as objects that follow permanent, invisible paths through space, but every object exerts a gravitational influence on every other object. Small changes accumulate over enormous timescales. Small gravitational pushes can eventually move asteroids to entirely different regions of the solar system. Stability exists, but it has limits that become apparent only through careful observation and long-term calculations. Then, astronomers discovered something even more astonishing. Sunlight itself can slowly move asteroids. When an asteroid absorbs sunlight and then releases that energy as heat, the escaping infrared radiation produces an incredibly small force. It's nearly impossible to detect in days or years, but it can gradually alter an asteroid's orbit over decades and centuries. Predicting the future path of a space rock sometimes requires understanding not only its gravity, but also its shape, rotation, surface, and how it absorbs and releases heat.
The solar system is affected by subtle influences far greater than human intuition would ever imagine. Perhaps the greatest surprise is that even if the laws of physics worked perfectly, prediction itself has its limits. Gravity hasn't failed. Our equations remain remarkably accurate, but the small uncertainties in today's measurements have grown over time, forcing scientists to simulate thousands of possible futures rather than relying on a single prediction. The limitation isn't physics. The limitation is that perfect measurements don't exist. Every new observation improves our understanding, but it never completely eliminates uncertainty. Space missions have reinforced this lesson time and again. Missions like Rosetta and DART have revealed that asteroids and comets are far more complex than once appeared, while showing that careful measurements could even allow humanity to slightly alter an asteroid's orbit. Each mission answered important questions, while also raising new ones, making the solar system resemble an active laboratory more than a finished map. What makes it even stranger is that every improvement in our instruments produces the same pattern. We almost never discover that space is simpler than we imagined. Only after years of observation do we discover hidden interactions, overlooked populations of objects, and subtle forces that have only recently become visible. Every new telescope, every spacecraft, and every precise measurement reduces uncertainty, but also reveals another layer of complexity waiting beyond. This may be the most unexpected discovery. The solar system isn't getting more dangerous because astronomers are constantly finding new asteroids. It only feels that way because each new measurement removes another layer of false certainty. The elegant diagrams in textbooks were never wrong, but they never told the whole story. Beneath those simple circles lies a restless gravitational system where countless invisible interactions are shaping the future in ways we are still learning to measure. Planets continue to obey the same physical laws as always. What is changing is our understanding of what those laws actually produce. And if something as familiar as our own solar system becomes more complex the closer we observe it, perhaps the greatest mystery isn't how dangerous space really is, but that so many other parts of reality still seem simple because we haven't measured them closely enough.